equation. What thing? We're not doing that. Now here's the thing. I looked at our SOLs again. There really isn't an SOL that says, I'm going to learn how to solve a one-step equation or a two-step equation. I'm going to learn how to solve an equation in one variable. The SOLs assume you know how to do that. We're just expanding on that. So if you don't know how to do it, you better pay close attention. I'm doing a review, but I'm not doing like you're somebody who has never seen an equation before. So I'm not going to take out the balance. I'm under the assumption we understand. We want to keep the equation in balance on both sides of the equation. So here's my review. You have to do it again. Yeah, I can have you say like shush, right? Okay, so an equation is an open sentence where two expressions are set equal. Right, that's what goes in that blank. Two expressions are set equal. That's an equation. Equations may have one or more unknowns. What's another name for unknowns? That variables, which we may try to solve. Well, what does that mean? Solving an equation means finding the values of variables that make the equations true. Yeah, that's not the answer. We like to say, oh, the answer is 2. The solution is 2. Because when you plug 2 back in, you get a true statement. Equations that have the same solution are called, and you may or may not know this word, equivalent. So two equations that both have x equal 2 as a solution are equivalent equations. This one, I don't know if you're going to get this one. We use what kind of operations to solve equations? You think you know, Ryan? What do you think? Ordered? I'm looking for a different word. I'm looking for the word inverse. And what does that word inverse mean? What does inverse mean? Opposite. So if you're adding on one side, then I'm going to be doing some subtracting. I do opposite operations. And this is new. This you have not done. This is what we're adding on with our new Algebra 1 SOL. We have to justify our steps. Anybody in this room solve equations by kind of guessing and checking? You know what I'm saying? It's like, looks to me like the answer or solution is going to be 3. I don't know where you get these numbers from. Some of you are really, really good at this too. You're like, 3. And then you just try it after you try that. Yeah, it works. We have to not be doing that. If that's how you got by Math 7, or if that's how you got through Accelerated, you got to learn how to solve it properly, because we are going to justify everything we do. In mathematics, you cannot do anything without a real justification for it. We're going to be using properties, okay? And we're only solving right now equations in one variable, but all these things are true, and you have more than one variable. We'll do that this year too. Isolating the variable is a big deal. What does that mean to isolate the variable? You heard those words before? What does that mean? What does it mean?
It means to like to put it alone.
Yes. Yeah. Like if you ever hear of like they put the prisoner in isolation, right? All by him or herself. So isolate means all by itself. So putting variables on one side of the equal and numbers on the other side. That's when we do these inverse or opposite operations. And this is kind of the golden rule of equation solving. Whatever you do to one side of the equation, you do to the other, and that can't be new. Come on, that's not new, right? No. So if you add 5 to one side, you better add 5 to the other. And that is that balance idea you were mentioning. It keeps everything in balance. This is important too, and I know for a fact that a lot of our teachers do. Every teacher does this. They say verify the solution. How do you verify the solution to an equation? How do you do that? You plug her back in, right? And everybody says they know it, and almost nobody does it. See here in big red letters with a lot of exclamation points. And it's on your paper here in bold and caps. Do not skip this step. I want everybody to circle that. You see it on your paper? Do not skip this step. Circle that and put stars next to that. This is important. I will tell you, I do this to this day when I solve an equation. Now maybe I don't always write it down anymore, but I do in my mind plug it back in, and I know I am correct. You should never ever turn in the paper with one wrong, unknowingly with one wrong. Because you plug it back in, you'll know if you're right or wrong. That's what's good about equations. It should take some of the pressure off. Because you know if you're right or wrong by plugging it back in. Okay, so let's do some examples of solving equations, and I don't think these are on here, so we're just gonna look up. Maybe they are, I'm not sure. Okay, yeah, this is actually on page 2. We'll come back to page 1. It's a little bit out of order here. But if you go to the top of page 2, see them? Yeah, it's done for you, so look up here. Now, is anybody here going, I'm going to pick the magic number, and I'm going to pick the magic number 10?
Yeah.
Now, how are you getting that? How are you getting that? You have 6 and 4, and you know it's backwards? Here's how you do this using algebra. You say, here's minus 4. What's minus 4 plus 4, right? When you add opposite numbers, what do you get? What do you get? 0. Because I want x plus 0. I want x by itself. So you do this little plus 4 thing here.
Oh, I remember this.
Plus 4 thing here. Some teachers said, draw a line here, do all this. I don't care if you draw a line or not. I'm not going to draw a line. Well, what is minus 4 plus 4? So you have x plus 0, which is x. And what's 6 plus 4? 10. Now you've solved the equation using properties. You've used the property to learn the name of the property. How do you verify it? Verification is what we did, I believe that was either last class or the one before that. You plug it in, but I want to see this process. You're looking, here's the process I want. You say x minus 4 is 10. So that means wherever x is, I plug in 10. Now you work on one side here. What's 10 minus 4? You work on the other side, well that's already a single number. Number compared to number. This is called the reflexive property. Now I put my check. It works. Verified. Now if you go down here, you got an 8. Let's say you did this wrong by mistake. Will anybody ever do it? I think it's 12 if you make a mistake. Here's where it doesn't work. So you'll get 8 and you'll be, oh wait a second. That means this is not a solution. I made a mistake. I need to try again. So if the verification does not work, it means you made a mistake. Possibly. You could sometimes make a mistake here. What I do when it doesn't work is I say, wow, I'm just going to circle this one. I'm going to do the other ones. When I go back and do this again, I'm doing it on a fresh sheet of paper. I'm not looking at what I did before because you can tend to make the same mistakes again and again if you just kind of look at what you did. So I recommend kind of do something else and then try it again. All right, so x plus 3 is negative 5. Now, it's a little bit harder when you have negative numbers. But is anybody picking like some magic number out of the air and saying, I think it's negative 8? Now, it's already harder to pick this out of the air. So if I'm adding 3, but I really want x by itself, I do the opposite operation because adding opposites gives me a 0. I get an x plus a 0. But whatever you do to one side, you do to the other. Now, negative 5 minus 3. If your integer skills are not so good, right, then you do have a calculator to help you, or you can just really practice them. Okay, 4x equals 16. Anybody just plugging 4 out of thin air? Oh, I forgot to verify. So you say negative 8 plus 3. Is that the same as negative 5? Add these up. Add these up. I want this level. Don't stop here. I know you see it. Do the math. Yes?
I got my point, so I'm going to verify.
Okay, yes. Now you're going to verify, right? Yep. Okay. All right, so 4x equals 16. What if I don't see a sign here, so what am I really doing? What's the operation? Yeah? Multiplication. So what should I do? Right? The opposite of multiplying is dividing. What should I divide by? 4. Why? What's 4 divided by 4? What's 4? 1, you get 1x. What is 1x? It's just an x. If you divide 4 on one side, you divide 4 on the other, and then we verify. So 4 times 4, is that the same as 16? Number compared to number. Now these are simple ones, right? We're starting simple to demonstrate process. Okay? We're demonstrating a process. These will get harder, but these are the steps I want to see. I want to see you doing all this and then verifying your solution. All right. Field properties. I'm going to go back quickly. I'm sorry. We're jumping around a little bit. Back to page 1. Okay, so this is really your introduction to proofs. When you get to geometry next year, it's all about proving stuff in math. this is a proof for an equation. We're going to use properties of equalities to justify all the steps. So we have to go through these properties, okay? The reflexive property of equality just says, if you have A and it equals A, yeah, that's true. That's like saying 6 equals 6. And we get to that reflexive property when you do the verification step, right? Symmetric property of equality is kind of an awesome little thing. It says if A equals B, then it naturally follows that B equals A. So if you say 3 equals X, you can just turn that around and say X equals 3 using the symmetric property of equality. Yes, sir? This is not the commutative property. Commutative property is of addition. A commutative property is, or multiplication, that's this. It's not the same thing. Now look how that's different. Okay, I'm turning around stuff in the expressions, so I'm not changing the expression, I'm just changing which side of the equal it belongs on. Excellent, excellent question. Fantastic question. Transitive property of equality is an awesome little property. We don't use it much in algebra, we use it a lot in geometry, but you still have to know it in algebra. I will say this is a favorite SOL question for some unknown reason to me. They love to ask something about the transitive property. It states, if A equals B and B equals C, then it follows that A has to equal C. Right? So, I'm going to think of an example. If X equals 3 and 3 equals Y, then X equals Y, because they both equal the same thing. An example of transitive property. Using it a ton next year. Tons and tons. So remember, put a little star here. They will ask you about that, and you always forget it because we don't use it a lot, really, in algebra 1. Substitution property you've already used when we did our expressions lesson. If A equals B, then A can be substituted for B. That's like when we have X plus 4, and now I'm going to say X has the value 10, so I can plug a 10 in here, right? That's substitution. You know they're equal to something else. And it's similar in a way to the transitive property if you think about it. So far, any mysteries? Nope. Not really. Now these are the ones we're going to use a lot in justifying steps in solving equations. So these look complicated, trust me they're not. If A equals B, then A plus C equals B plus C. This just says you can add the same thing to both sides of an equation and you still have equal. It's still an equation. So that's when you're solving this equation, x minus 2 equals 7. So you know how you add 2 to both sides? Who says you can do that? The addition property of equality. That's who says so. It's all about who says. And what's nice is because you're adding, it helps you remember, it's the addition property. The subtraction property is the other way. If you subtract the same thing from both sides of an equation, it's still equal. That's when you have x plus 3 equals 7. Well, how do we solve that? We subtract 3 from both sides. Who says you can subtract 3 from both sides? The subtraction property of equality. Multiplication, what do you think this is? The multiplication property of equality. It says you can multiply the same thing on both sides of an equation. So if I have 1/4 x equals 5, I can multiply both sides of the equation by 4. Who says you can multiply both sides by 4? The multiplication property of equality. Now why am I doing that? Because it will cancel these out. I get my x by itself. And I can solve my equation. Remember that? No. Multiplying by that reciprocal, I believe the word is? Yes. Okay, I hope so. And then the division property of equality. Now this one has a little extra stuff. I'll talk about that in a second. But you can divide both sides of an equation by the same thing as long as it's not 0. Remind me to go back to that. So that is 3x equals 9, right? So I'm going to divide both sides by 3. Who says I can divide both sides by 3? The division property of equality. I do that so I can isolate my x. I'm getting back to why can't I just put, why do I need to say c can't be 0? Tell me the answer to this. That's a 4 over 0. 0?
No.
Well, why isn't it 0? Remember how it works? Like if you have 6 over 2 is 3, remember I can multiply back? So 0 times 0, well, that's not 4. Well, that doesn't work. Well, it's 4 over 0. Yeah?
Yeah.
Well, we just tried 0, it doesn't work, because when I multiply back, I don't get 4. Here's something very important. Everybody's going to write this in very, very big letters on the note somewhere. Dividing by 0 is undefined in mathematics. Anybody have their calculator with them?
Yeah. No.
Put in 4 divided by 0, see what happens. And what? Stand back, it might explode, I'm not sure.
I want to try this.
Why is it saying error? Because it is undefined in mathematics. Believe it or not, I'm telling you, I'm cringing just looking at that. Now, what, is that the same as 0 over 4? Can I have a 0 in a numerator? That is mu, because look, that works. So you cannot divide by 0. Cannot. That's why we put this little note here. You can't put zeros there. Everybody write that in big letters. This is going to come back to get you if you don't remember that. Cannot divide by 0 in mathematics. Awesome. Alrighty. Let me see where we are here. You can turn the page again. Justifying steps. So here's how we're going to solve equations, justifying everything we do. This is, now back on page 2, and we're kind of redoing or doing similar ones to the ones we just did. Going to solve x plus 4 is 10. Now some of you are pulling that number out of the air. 6! But we're not going to pull it out of the air. We're going to use the justifying steps. So here's my given equation. If we're being very thorough, we're going to say that's my given equation. What do you do next? Now I'm going to write it the long ways. You don't have to write it the long ways, but I am. Because I think we lose track of what we're really doing when we do that little -4. What did I change from here to here? What changed? Well, let's say I subtracted 4 from both sides. So who says, based on the properties we just learned, who says you can subtract the same thing from both sides of an equation and it's allowed? It's legal. Who says? Awesome. The subtraction. And you have to kind of write all these words. Now, I will allow abbreviations of equality. When you have an equals, you can say that. Now, let's say you have a less than, maybe or maybe not. It's important to have this of equal. Well, you want it wrong if I don't put the of equal? Yes. Okay. All right. So now we're going to combine our like terms here, or simplify. And that's where this comes from. Now, it's an awful lot of work, right, for something that we know exists. But we're doing this to learn a process. You guys with me?
Yes.
Okay. And then, of course, you verify your solution. So you say 6 plus 4, is that the same as 10? If you stop here, you haven't verified anything. Add that, compare to the right side, it works. Let's try this guy. All right, so this is my given equation. How do you solve this? On x, I isolate the x here. What do you think, Danny? Awesome. Did everybody remember that?
Yeah.
It's called multiplying by the reciprocal. Why do we do that? Because Miss Baird said so. Like, no, why are we doing that? Why do we do that? They cancel each other out. Because this is called cross reduction, right? I'm left with my 1x. That's what I want. Right? Now, first of all, I multiplied something on both sides of the equation. Okay, so I'm going to put this on the next step. Right? Instead of messing up what I had there. Who says you can multiply the same thing on both sides of the equation? Who says? Yep. Look on the first page. I'm multiplying the same. Now, I'm using the inverse property to choose what I'm multiplying by, but I'm doing it on both sides. Who says? Try again. Multiplication, property of equality. Okay, now I'm going to do all that work. This goes away. Oh, what about this guy? That becomes a 2, right? 2 times 3 is 6 over 1 times 1. 6 over 1. X equals 6. Simplify that.
What happens if the function doesn't equal,
What, here? Yes, x can be a fraction, absolutely. And if x is a fraction, do not turn it into a decimal. If x is a fraction, we're very happy to have it. My preferred form is improper, not mixed, but it has to be in simplest form. Okay, and now we verify. 2/3 of 6. Is that the same as 4? Well, let me see. That crosses out. 2 times 2. You bet with fractions, you better go verify these. It's easy to make mistakes. You want to make sure you're correct. And who's with me? All 3 of you. Awesome. Okay, we got a few more. All right, I want to look at 2 steps real quick because, again, you should know how to do this. With 2 steps, it means that it's not as simple as what we were just doing. You may have to do some distribution. Who remembers distribution? Yeah. How do you distribute this? Ben?
I was thinking like 2 arcs right there.
Yep.
Same 3x times
3x plus 3 times 2. What if it's, make it a little harder? Now I do the same thing, I make my little arcs, right?
yeah.
So Cole, what happens
And
here?
then you do 2 times x,
-2. I like to circle this. -2 times x.
and then
Careful, careful, careful. Watch what I just circled that with the sign now. What's a negative times a negative?
positive.
What's a 2 times a 5? If you circle and are very careful with the signs, when you've got negatives, you won't mess up this sign anymore. Is this familiar to anybody in this room? The distributive property and doing that. This should be something you did last year. Okay, not everybody's raising their hand. Either you're shy or you really don't know, which is stuff that you got. So I actually did the steps here because remember the SOL is not, do you know how to solve a 2-step? Can you justify? So when you have something like this, the first thing you do is you subtract 9 from both sides, right? Isn't that what changed from here to here? Who says? Subtraction property of equality. So as long as you identify the operation you're doing, the property is pretty easy. Now here to here, all I did was I just simplified that down. I subtracted out these numbers. And now I'm dividing both sides by 5, right, to isolate the x. Who says? Who says that you can just divide by 5 on both sides just like that?
You.
Me? Besides me.
Division
Division property of equality. And then I'm going to simplify that down. And I'm going to leave that for you to finish this verification because I want to talk a little bit about what's going to happen. We usually don't write out the simplify steps. This is where I want you to be. You may or may not be there. You start with your given, and then look, it just jumps to the next step. Well, how did I get from here to here? What did I do? I subtracted 9, right? I actually did use the subtraction property of equality, but I'm just getting better at how to solve equations. I'm not necessarily showing it. Now, if you still want to do this, be my guest and absolutely go ahead and do that. Now, what would the next step be? How did I get there? What did I do? What did I do? Yeah, it's the division property of equality. This is, because we're first learning it, I'm showing every little step, but this is how I do it. Now, if you still put this little 5 here, you can do that. You can still do that. But I want to see these properties. All right, let's try the other example here. Oh, okay. Yep, I'm on the middle-ish page 2, right? So I'm getting x over 2 minus 5 equals 11. Added 5 to both sides. Who says? Addition property of equality. And then this one still has the simplify step in there. Then I'm multiplying both sides by 2. Who says you can multiply both sides by 2? Nope. Bigger than him. No, I'm multiplying. Multiplication property prosperity of equality. And then we simplify it again. Definitely want to verify all your equations. I am saving time a little bit. I'm going to let you finish that. But remember, I need number compared to number for it to be true. If I wanted to do this without all the extra steps, this is how I do them. There it is, which means x over 2 equals 16, using addition property of equality. So you don't really see every little in-between step. And then I'm saying x equals 32, because I am doing the multiplication. Now, obviously, I've been doing this for at least 150 years. Certainly feels like it. You are still adding 5, adding 5. I am perfectly fine with that. Multiplying by 2. You can do that, but these are the properties I want to see, the justification steps. Okay? You know what I'm saying? Not like this, if you know what I'm saying. Nobody's doing it. Okay, thank you, Melina. Nobody else knows what I'm saying? Thank you, she does. Nobody else does. Okay. That's all good. Let's look at this guy. Is this on here? Yeah, this one is actually, yes, right underneath. 3x plus 2. So, what do you do first? Yeah, what do you do? Okay, Ben? Combine like terms, right? And you can write, that's what I did. Because what's 3x plus 2x? You have 3 x's. I give you 2 more x's. How many x's do you have? 5 of them. And I'm making a leap here. How did I get here? What's the property?
What property?
Yeah. I hear it. Division property. Equality. Now your paper shows the intermediate steps, or it doesn't show anything, right? Yeah, I'm just doing that. Now, could you have said, I need to see this, and I'm perfectly fine if you need to see it. Put it on there. Okay. Oh, look at this guy. Whew. Now what am I going to do? What do I do?
4x times
4x minus,
minus 24.
right, distributive property. So what's the reason? The distributive property. You're justifying your step. That's a property that you know, mathematical property. Distributive property of multiplication or addition. You can just say distributive property. What? You do 4 times x minus 4 times 6, which is 4x minus 24. Okay, can I add these 2 things? Can I subtract these 2 things? Are these like terms if it has an x and it's a number?
No.
So the next thing I'm going to do is what? What's the next thing we have to do to solve this? Add 24, right? I want to get the x term by itself. You're gonna be doing this, right? So I'm going to get 4x equals 56. Is that right? Yeah. And who says I can add 24 to both sides? Then addition, property of equality. Okay, now what am I doing? I'm dividing by 4. You can put the little 4 in there. I'm dividing. X equals 56 divided by 4. 14, right? Now 14? We should verify to make sure. We will. So that's, I divided division, property of equality. Definitely, I mean, you want to verify all of them. This one's a little harder. So you say 4 times, I'm going to put the x, I think it's 14. And I'm working here. That's 4 times, that's 14 minus 6. And you may see it already. That's great. Number compared to number. And I know I said that on the checkpoint. Most people, or a lot of people, didn't do it. First they didn't show it, or if they only did maybe 1 line of this, people who did it correctly showed them all this. Who's with me so far? Come on, who's with me? And if your hand's not up, you know I'm going to come get you. You guys aren't with me over here. You're lying. We don't get it? Oh, no, I get it. My hand's up there. Okay. I get it. All right. So I got a few U-tries here. Before we do that, I have to cover something else. So let me just get there. This I don't believe you did last year. Maybe you did, maybe you didn't. Look at that. There's an X here, and there's an X here. What?
I can do that.
What do you do?
Add 1.
Oh.
Or
Maybe what?
subtract, first of all, you have to subtract the smaller x. Then you
Yeah,
have to take
wait,
it off.
are you guys listening? You know, you guys, I will be moving, I'm pretty sure. I don't have anywhere to move you, it's a big class. Stop it. You have been warned. Alrighty, so he just told you how to do it. So what'd he say?
You see,
What, no, what'd he say? See? Okay, he's saying, here's an x, here's an x. I'm going to use the subtraction property of equality to subtract an x from both sides. Because what's x minus x? X minus x. You have an x in your hand? I take it away. What's left? 0. X minus x is 0. You have two x's. I take away one of the x's. What's left? 1x plus the 1 equals -3 using subtraction property of equality. Now I'm going to subtract 1, right? So x equals -4. I'm using the same property. And I think I'm done. Now, are these good ones to verify? Yes. Because these are much harder to see in your head. And again, work this side, then work that side. What's 2 times -4? -8 plus 1. What's -4 minus 3? Now, if integer addition and subtraction is a really hard thing for you, then you got to practice them all or use your calculator. What's -8 plus 1? And that's matching now. So now that these are a little more difficult, you really, really, really got to do your verification step. Let's see, and I think I have another one with multi-step. Okay, so here, see how there's x on both sides? So what can I do? The idea is get all the x's on one side and all the numbers on the other side. So I find if you have a negative and a positive, it's a little bit easier to add that. Because what's -3x plus 3x? Are these opposite numbers? They're 0. If you add 3x to one side, you add it to the other. So this is different actually than what's in here. All right, I'll go back to this, but never mind. It's different than what I have in the notes. Okay, watch what's going on here. I am subtracting 4x from both sides on this step using the subtraction property of equality. Why am I doing that? Because what is 4x minus 4x? Right? It's gone. Now I only have x on one side. And now you should know what to do, right? You're going to subtract the 7. That's what I'm doing next. Again, subtraction property of equality. And I get this comes to -14, and this is -7x. Divide by, -7, and I get my x equals 2. Now this is new, okay? This part I know is new. Yes, question?
What's the thing on the end of like it says subtraction property? That like
Of equality.
Oh, okay.
Of equality, of equality. Has to be there or it's wrong. Has to be there. Oh, goodness gracious. Yeah. No question? I'm still not sure what to ask. Look at this thing. Are you kidding me? Well, what should I do? How do I clear parentheses?
Combine the current.
You're going to distribute.
Oh.
You're going to distribute. So 1/4 of 16, 4x. 1/4 of 60 is 15. Right now, I guess here. What I did was I subtracted this 4x to the other side. Because what's 4x minus 4x? 0. So that was the subtraction property of equality. Then I got here, what did I do? I had added 5. So this one may be the trickiest bit that we have. Stop here. Yeah, I'm going to leave that one for now. I think what I'm going to do is just kind of pause here, stop here, and we'll do some more of this next class.